Right now, global enterprises are pouring, roughly $40 billion into AI investments.
Yeah, that's a massive number.
It is, and according to the latest research, well, about 94% of them are getting absolutely nothing in return.
Right. No measurable value, no revenue bump, nothing.
Just a massive pile of sunk costs. So, welcome to this deep dive. If you walk into any corporate boardroom today, enterprise AI is just the unmistakable elephant taking up all the oxygen in the
Oh,
room.
absolutely. Everyone is throwing money at it.
Right, and everyone is secretly terrified because they have no idea how to actually tame it. So whether you are an executive trying to justify this astronomical technology budget or just a professional wondering exactly how these tools are going to reshape your daily workflow, this is your ultimate shortcut. We are cutting through the hype to find out what actually works.
And to do that, we are synthesizing a pretty phenomenal stack of intelligence today.
We really are.
We're pulling from academic governance frameworks out of Columbia University, some really hard economic hardware analyses from Lenovo and Forrester, and deep organizational change management playbooks from Infosys.
Plus, we are pulling heavily from the actual deployment trenches, right? We've got hard-hitting strategies from Alice Labs, MLQ.ai, Paolo Cignoli, Peter Tegelar, and the 70-day enterprise roadmaps developed by Stryker AI and Ryan McMillan at Ryan Tech.
Yeah, we have the data, the blueprints, and obviously the cautionary tale.
Exactly. Okay, let's unpack this, because before we can build a successful integration, we really have to look at the mechanics of why almost everyone else is just absolutely crashing and burning.
Yeah, what's fascinating here is the sheer scale of the failure rate. It's sobering. Paul Cignoli's recent analysis highlights that, 91% of enterprises are currently using AI in some form.
Wow, 91%.
Right, but only 6% are capturing measurable business value from it. And MLQ.ai's research mirrors this perfectly, noting that 95% of organizations get zero return on that $30 to $40 billion global investment pool.
Wait, I have to challenge that right out of the gate. I walk into any office today and I see teams using chatbots to write code, to, generate marketing copy, summarize meetings.
Sure.
It feels like everyone is getting value. So how can 95% be failing?
Well, the disconnect there is between individual convenience and measurable enterprise ROI.
Right.
An employee using a chatbot to save 20 minutes on an email, that is adoption. But it doesn't fundamentally change the company's operating margin.
Right, that makes sense. It's not moving the needle on the balance sheet.
Exactly. When Cignoli looks at the failures, he points to this massive strategic blind spot, which is integration costs. The prevailing myth out there is that the AI model itself is the expensive part.
But it's not.
Not at all. In reality, building or licensing the model is maybe 10% of the work. The other 90% involve all the unglamorous stuff, the data pipelines, the API gateways, security access controls, the audit trails.
Oh, wow. All the background plumbing.
Exactly. When you try to plug a shiny new AI into a 20-year-old legacy ERP system, you suddenly incur costs that add 20 to 30% to the total project budget. And nobody plans for that.
It's like spending your entire renovation budget on a flashy, solid gold front door and completely forgetting you need to pay a plumber to make the pipes work in the house.
That is a perfect analogy.
You have this beautiful entryway, but the structure itself is literally uninhabitable because you didn't run the plumbing.
Right, and look at where those renovation budgets are being directed, to use your analogy. MLQ.ai's research shows that roughly 50% of generative AI budgets are just poured straight into sales and marketing.
Right, because everyone wants the flashy outbound email bot to show the board, right?
Exactly. But proving a direct, undeniable return on investment from a marketing AI tool is incredibly messy.
Because there are too many variables.
Yeah, you're dealing with so many external factors. Did sales go up because of the AI copy, or, I don't know, because the market shifted?
That's a really good point.
Contrast that with the highly structured back-office operations, things like finance, procurement, or displacing outsourced BPOs.
And just to clarify for anyone unfamiliar, BPOs being business process outsourcing.
Yeah.
Those massive external call centers or data entry hubs that companies pay millions for every single year.
Right. Automating those internal operational tasks is where the real multi-million-dollar savings live. If an AI handles 50% of your vendor invoice processing, you instantly see the savings on the balance sheet.
It's just simple math at that point?
Yeah, but it gets ignored because it isn't visible or exciting. Companies are viewing AI as this magic wand to generate revenue rather than treating it as a rigorous software engineering project meant to automate complex operational costs.
Okay, so treating it like a magic wand leads straight off a cliff. If we actually want to be in the 5% of companies moving the needle, what is the map? I mean, how do we escape this pilot purgatory?
The organizations that actually succeed introduce uncompromising structure. The consensus across Alice Labs and the deployment models from Stryker AI is that you need a highly specific 70-day roadmap.
A 70-day roadmap. Okay.
It's essentially a 10-week proof of concept window.
Mhm.
But the absolute most critical part of that framework is week one.
What happens in week one?
Well, week one cannot involve building a model. It must be a rigorous data audit.
Oh, I imagine that's because Gartner estimates that 63% of organizations simply do not have AI-ready data.
Exactly.
But what does that actually mean? Like, why is the data so unusable for these companies?
Well, legacy data is rarely structured for machine learning. It is usually siloed across different departments. Marketing uses one platform, finance uses another. It's largely unlabeled. But the biggest hurdle, by far, is privacy and compliance.
Ah, right. The legal side.
Yeah. Imagine trying to feed a decade's worth of customer service transcripts into a large language model. If that data isn't scrubbed of personally identifiable information, credit card numbers, social security numbers, you are instantly violating data privacy regulations like GDPR.
That sounds like a massive lawsuit waiting to happen.
Oh, it is. If you skip the audit, you will hit week 3 of your 70-day roadmap, realize your data is a compliance nightmare, and the entire timeline just collapses.
Okay, so you audit the data first and you scrub it. What happens next? Because in a massive enterprise, you might have, I don't know, 50 different department heads all pitching their own pet AI projects. How do you objectively decide which ones get the green light?
So Peter Tegelor developed a playbook specifically for financial institutions that tackles this brilliantly. He uses a 6-dimension scoring system.
A scoring system.
Yeah, it forces every AI initiative to be scored objectively on criteria like strategic fit, business value, technical readiness, data availability, and risk.
Yeah.
It completely eliminates the loudest executive syndrome.
I love that. The loudest executive syndrome.
Right. A project only moves forward if it proves it has the foundational elements to actually succeed.
Taylor also pairs this with 5 levels of AI autonomy to manage the inherent risk, right? I thought that was really interesting.
Yes, mapping out the autonomy is crucial. Level 1 is AI informs. That's like summarizing a lengthy compliance document where a human still does all the actual work.
Okay.
But level 5 is full autonomy. That's where the AI is executing financial trades or approving loans with zero human intervention.
Which is terrifying if it goes wrong.
Exactly. You have to explicitly define where your proof of concept sits on that spectrum before you begin. Because a level 5 system requires exponentially more rigorous testing and guardrails than a level 1 system.
And tied to that risk management, I noticed these frameworks heavily stress something called the kill condition.
Oh, the kill condition is vital. It's a pre-committed threshold to terminate a failing project. You decide, literally before you write a single line of code, exactly what metric will cause you to pull the plug.
Because otherwise people just keep throwing good money after bad.
Exactly. The sunk cost fallacy takes over. Failed pilots just drift endlessly, consuming budget and engineering capacity because no one wants to admit defeat.
So you have your audited data, you have your objective scoring system, and your kill condition is ready. What do you actually build first in this 70-day sprint? Because Paolo Cignoli has a piece of advice here that I found really counterintuitive.
The boring model.
Yes. He says you should build the boring model first.
Yeah, before an enterprise even touches complex generative AI or autonomous agents, Cignoli argues they should build a simple XGBoost predictive model on tabular data.
Okay, let's pause right there because we just hit some pretty heavy data science terminology. For those of us who, don't spend our weekends coding on GitHub, what exactly makes an XGBoost model boring compared to a tool like ChatGPT, and what is tabular data?
Sure. Tabular data is simply information organized in rows and columns. Think of a massive Excel spreadsheet or a standard SQL database. Sales figures, dates, customer churn metrics.
So just normal business data.
Right, it is highly structured. And XGBoost is this highly efficient mathematical algorithm designed to analyze that specific kind of numerical data and make predictions.
Okay, so no talking robots.
Exactly. It doesn't write poetry, it doesn't chat with you. It looks at your historical data and predicts, say, which customers are most likely to cancel their subscriptions next month. It is boring because it isn't conversational.
Here's where it gets really interesting, because if we are spending the first month of our 70-day roadmap auditing spreadsheets and building boring predictive models, are we going to lose the AI arms race to competitors who are launching flashy chatbots tomorrow? I know executives are terrified of moving too slowly.
I hear that constantly. But disciplined deployment beats chaotic speed every single time.
Really?
Yes, a boring tabular model trains in minutes, not months. It costs literal pennies to run. But most importantly, it establishes a hard, undeniable financial baseline. You can walk into the boardroom and say, look, this predictive model reduced customer churn by 4%, saving us $2 million.
Wow, okay.
That tangible ROI is what you use to fund the more advanced, expensive generative AI projects later. Furthermore, this approach aligns perfectly with Columbia University's AI governance framework, specifically their principle that AI is accountable.
Meaning humans have to oversee the outcomes and actually understand how the machine arrived at its conclusion.
Exactly. You can't just unleash a complex neural network black box and hope for the best. You build the accountable model to prove the value, and then you layer the deeper intelligence on a solid foundation.
Okay, let's say you follow the blueprint. You've planned your structured proof of concept, you built your XGBoost model, it hit the ROI metrics, and now the board is thrilled.
Time to scale.
Right. They say, great, now scale up those massive intelligent generative AI workflows across the whole company. But this is where the financial model often shatters, right? Because we have to talk about the physical price of intelligence, the real compute costs.
The physical infrastructure is the next great bottleneck, without a doubt. Lenovo's 2026 Total Cost of Ownership report introduces the metric that is currently defining enterprise success, which is token economics, or more specifically, tokens per second per dollar.
So we are moving away from traditional IT metrics like server uptime, and instead we're measuring exactly how much intelligence we get per dollar spent.
Precisely.
I've got the Lenovo data here, and to understand why those costs just explode, we have to understand something they call the memory wall.
Oh, the memory wall is fascinating. When you train an AI, it uses these massive bursts of raw computational power. But when you are running an AI in production, which is what we call inference, the act of generating the actual responses, it's a totally different workload.
Oh, so?
It requires persistent, continuous, latency-sensitive utility. To generate a response, the entire model has to be loaded into the GPU's short-term memory, the VRAM.
And these models are massive. I mean, the Lenovo report uses a 70 billion parameter model for their baseline. Parameters being the billions of individual connections or variables the AI uses to make decisions.
Right. So imagine trying to hold a 70 billion piece puzzle in your active memory. For every single token or fragment of a word that the AI generates, the system has to move those massive model weights back and forth from the memory to the compute units.
That sounds incredibly taxing on the system.
It is. It creates an incredible traffic jam inside the hardware, which is why renting this capability in the cloud becomes astonishingly expensive for sustained, heavy usage.
The cost comparisons Lenovo ran on this are just jaw-dropping. They calculated the cost to generate 1 million tokens. If you use a Frontier API, essentially renting intelligence by the query from a provider like, OpenAI or Anthropic, generating 1 million tokens costs about $2.
Which seems cheap until you scale it across 10,000 employees asking queries all day long.
Exactly. It adds up so fast. Now, if you take a step inward and rent your own dedicated H100 server on the Azure cloud, that cost drops from $2 to 89 cents.
A good improvement.
But here's the kicker. If you own the hardware, specifically Lenovo's on-premise infrastructure, amortized over a standard 5-year hardware lifecycle, the cost to generate that same 1 million tokens plummets to just 11 cents.
From $2 all the way down to 11 cents, the margins are undeniable.
It's essentially the difference between taking an Uber everywhere you go versus buying a reliable commuter car.
I love that comparison.
Yeah, I mean, the Uber is fantastic for a weekend trip to a new city. But if you are commuting 50 miles every single day, renting your transportation by the mile is going to completely drain your wallet.
Right. The cloud is absolutely essential for that bursty experimentation phase, or for companies just running their initial 70-day proof of concept. But Lenovo's analysis proves that once you reach heavy, sustained inference usage, on-premise hardware actually breaks even in less than 4 months compared to cloud API pricing.
Less than 4 months.
Yeah. Owning your own inference factory has become a financial imperative for scaling.
And it is a serious capital allocation. I was looking at the Forrester Total Economic Impact report on deploying an Oracle digital assistant. They noted that a typical enterprise deployment involves about $595,000 in risk-adjusted initial and ongoing costs over 3 years.
That's a huge commitment.
You don't spend $500,000 without a solid long-term infrastructure plan. You really have to treat AI compute as core utility infrastructure, just like your power lines or your internet connection.
Absolutely. So we've mapped the strategy, we've structured the data, and we've solved the budget with token economics. But there is a final pillar, and honestly, it is almost always the most neglected.
The human element.
Yes. None of this technology matters if the people in your organization actively resist it or simply don't know how to work alongside the machines. We have to talk about human change management.
This brings us to the perspective of Ryan McMillan at RyanTech. He argues that AI must be viewed as a force multiplier, not a replacement, which, goes against a lot of the aggressive cost-cutting narratives we hear in the media.
It does, and McMillan points out a fatal flaw in that cost-cutting mindset. If an executive uses AI to outright replace human workers, they are permanently deleting institutional knowledge that a machine simply cannot replicate.
Right, all that context.
Exactly.
Right.
And AI is exceptional at processing vast amounts of data, but it lacks the contextual human intuition about your specific business relationships. It doesn't know why a particular client prefers phone calls over emails or, the unwritten history of a troubled vendor relationship.
He also draws a really sharp distinction between AI adoption and AI implementation, which I thought was brilliant.
Oh, it's a critical difference. Adoption is easy. Adoption is just buying 1,000 licenses and giving your team access to a chatbot. Implementation is incredibly hard. Implementation means aligning those tools with your specific business goals, setting up safety guardrails, and establishing rigorous human oversight.
To manage that implementation, Infosys actually developed the concept of the augmented manager.
Yes, the augmented manager.
Traditionally, a manager spends a huge portion of their week on routine task allocations, status updates, just summarizing data. Because AI can handle that administrative burden, the manager's role elevates.
They get to do the real work.
Exactly. They start acting more like a workflow designer, figuring out how to piece together different AI capabilities, and like a coach, fostering collaboration between the human team members and the AI systems.
And the day-to-day jobs themselves are changing fundamentally. MIT and Infosys identified 3 entirely new categories of jobs created by the necessity of AI.
Right, so first you have the trainer.
Trainers are the employees responsible for teaching the AI, fine-tuning its behavior with domain-specific knowledge, and ensuring it understands the nuances of the business. They are basically feeding it the right data.
Second, you have the explainers.
Explainers bridge the critical gap between the complex technology and the business leaders. When an AI denies a loan application or recommends cutting a supplier, the explainer interprets the model's logic and ensures that the recommendation actually aligns with corporate ethics and strategy.
And finally, the sustainers.
Sustainers are the watchdogs. They monitor the AI systems in live production to ensure they operate as designed over time. They are constantly looking out for model drift, which is when an AI's accuracy degrades as real-world data changes, or watching for biased outcomes.
To help employees transition into these entirely new roles, Infosys recommends setting up work labs. These are safe, sandbox spaces where employees can experiment with AI tools and literally map out what their future jobs will look like. So what does this all mean for you, the listener? If you were worried about AI taking your job, the strategy here isn't to compete with the machine on speed or data processing.
No, you will lose that race every time.
Exactly. The strategy is to step up and manage it, to become the trainer, the explainer, or the sustainer.
If we connect this to the bigger picture, it echoes a famous sentiment from NVIDIA's CEO. He pointed out that you aren't going to lose your job to an AI. You are going to lose your job to a human who knows how to use AI better than you do.
That is so true.
The companies and the individuals who win this era will be the ones who successfully combine the raw, scalable speed of AI with irreplaceable human judgment.
It is a profound shift in how we value human capital. Let's recap the through line here, because we've covered a massive amount of ground today. To escape that terrifying 95% failure rate and the $40 billion sinkhole, you have to completely ditch the flashy ad hoc pilots.
Right. You utilize a strict 70-day roadmap, and you start with a rigorous data audit. If your data is siloed and non-compliant, your project just isn't ready.
You build a baseline with traditional, boring XGBoost models to prove financial ROI before getting distracted by expensive generative AI.
Then you control your long-term scaling costs by understanding token economics, realizing that owning your inference hardware on-premise might be vastly cheaper than renting intelligence from the cloud.
And finally, you train your workforce not to fear the machine, but to multiply their own capabilities by stepping into those new roles of augmented managers, sustainers, and explainers.
That is the exact blueprint used by the 5% of enterprises who are actually succeeding today.
Good.
But there is one final concept from the MLQ.ai report that looks even further down the road past these current structural hurdles. They call it the agentic web.
The agentic web. Right now, our entire conversation has focused on humans using AI agents. The agentic web is a scenario where autonomous AI agents are discovering, negotiating, and executing contracts with other companies' AI agents entirely across the internet without any human mediation whatsoever.
It's wild.
Imagine your company's AI supply chain agent realizing you are low on a manufacturing component. It scours the internet, finds a supplier, negotiates the bulk pricing with their AI sales agent, and signs a binding contract in milliseconds, all while you are asleep.
And the technological capability for that is arriving a lot faster than we think.
Which leaves you with a massive, mind-bending question to ponder. What happens to legal accountability? If your AI makes a bad deal or hallucinates a phantom clause with another AI, who is at fault?
Who pays the price?
Exactly. Who pays the price when two machines misunderstand each other in a microsecond transaction? It is a wild frontier. But for today, before you worry about autonomous negotiating agents bankrupting the company while you sleep, make sure your tabular data is audited. Don't buy the solid gold front door until you've paid the plumber to fix the pipes. Keep exploring, keep asking the hard questions, and stay curious. See you on the next deep dive.